In this final set of examples, we're looking at what is known as a perpendicular line, and that's spelled like this, perpendicular. And that means that if you have a line like this, a perpendicular line will be at right angles to it, so it will look something like this, where this is a right angle. So we could say that the yellow line is perpendicular to the red line. Or we could say that the red line is perpendicular to the yellow line because that's right angles as well. And if I said that the red line had a gradient of, let's say, a half, that means that when you go across by 1, you go up by a half. What would the gradient of the yellow line be? Well, the yellow line has sort of been rotated 90 degrees. And so if we rotate that sort of triangle there 90 degrees, it will look like this. So if the red line here goes 1 across and then a half up, then I'm going to do that half again because you can't really see that. It's a half like that. Then we have the same sort of triangle down here where this is 1, or actually -1 because it goes down, and this would be a half. So what would the gradient of this yellow line be? The gradient is defined by when you go across by 1, how much you go up by. So if this is going across by a half and it goes down by 1, then if you were to go across by 1, it's effectively making this triangle twice the size. Then it would sort of look a bit more like this, I guess. If that would be 1 instead of a half, then this is scaled up to now -2. And the gradient of the yellow line would be -2. And the way that it always works is whatever the gradient of the red line is, the gradient of the perpendicular line is always -1 divided by the gradient of the red line. So if the red line had a gradient of, let's say the red line had a gradient of 3, the perpendicular line would look like this. And we work out its gradient by putting it into this formula and be -1 divided by that thing, which is 3. So that is how you work out the gradient of a perpendicular line. So let's have a look at the example 1 and see if we can put this into some sort of sense. So we have a line passing through the origin, which is the coordinate 0, 0, and is perpendicular to the line with this equation. Now they've tried to trick us here by not really following the y equals mx plus c look. So we should rewrite this with the x first, minus x, and then write the +7 after that. And the reason for that is because now we can work out what the gradient of this line is, because the gradient is important, because that's what we need in our previous equation to work out the gradients of these other lines. So the gradient here, the gradient is -1. So then the gradient of the perpendicular line, which is going to have the gradient of, I should do this as MP for perpendicular. So the perpendicular gradient is going to be -1 divided by this thing, which is also -1, which is 1. So the gradient of the perpendicular line is 1. And now if we know it goes through this coordinate, we could quickly graph it. We know it goes through this coordinate and has a gradient of 1, so it must do this. And we know that, if we label our x's, of course, we know that this is going to have the equation y equals x. And that is the equation of the line. Let's have a look at another example. Hopefully that will make a bit more sense. So we have a line passing through the points with these 2 different coordinates. Let's just graph it. So we've got our x and y. We have coordinates 2, 6, So 2, 6 here, and 5, negative 1 down here. And we know that a line passes through those two, so it's going to do this. And the second line passes through the coordinates 0, 3, so 0, 3 is here, and 7, 6, which is up here. So that'll do that, something like this. Oops, should go through there. It's asking now, are the two lines perpendicular? Well, to do this, we have to work out what the two gradients are. So let's do the gradient of the yellow one. And if you can't remember how to find the gradient from two coordinates, have a look at the video series about straight lines. And it will tell you that the gradient formula is y2 minus y1 over x2 minus x1. And using these two coordinates, it's these two here actually, isn't it? So this would be x1, y1, and this would be x2, y2. So we just have to put them into the formula to find the gradient of the yellow line. So y2 is 6, y1 is 3, x2 is 7, x1 is 0. So the gradient of the yellow line is 3/7. Let's do the same for the red line. So with the red line we have our two coordinates x1, y1 and x2, y2. And if we put that into our gradient formula, the same as this, we'll find that it's going to be -1 minus 6 over 5 minus 2. And this is -7 over 3. Now, are these two gradients perpendicular? We would need to say that if we did our formula, if we employed the formula that we did before, which is the perpendicular gradient would be -1 over the gradient of the other line. Well, if we said that the gradient of the other line was 3/7, then that would be -1 divided by 3/7. And when we divide if we do 1 over a fraction, it's got the same effect as flipping the fraction upside down or reciprocating it. So this would be 7/3, and that negative has come in there as well, so that'd be like that. And hey, look, that is the same as the gradient of the other line. So the gradient of the other line was -7 over 3, and that was -1 over the other gradient, so therefore they are perpendicular. Have a go at the exercises and let me know if you get stuck.